Hi guys, welcome to Code Wild, and I'm again back with another question. It's basically a question called triangle. It's a medium level question. So yeah, before I start the question, I want you to read the question once. I hope you read the question. So basically, what they're just asking is, they are given a triangle array. You have to find the minimum path sum from top to bottom, right? Basically it's like you consider this example. They have given 2 3 4 5 6 8, so it will be in the, if it's in the form of triangle, it will be like 2 3 4 5 6 7 4 1 8 3. So what will be minimum sum, in the sense for each row what is the minimum value. You have to sum it up till the bottom. That is, in the first row we have only one element, so 2 will be the minimum element. In second row, between 3 and 4, you will find that 3 is minimum. So this will be the minimum. In the third row, 5 will be the minimum. Fourth row, 1 will be the minimum. So what is the minimum sum of these elements? That is 2 plus 3 plus 5 plus 1. So that you have to return that, the minimum sum. Alright, so yeah. So it's basically a DP problem, dynamic programming. You can solve this either using memorization method or using bottom-up approach. I personally prefer going through the iterative bottom-up approach. Even in these approaches, there are two options. You can either go top-wise, I mean from top to bottom or bottom to top. How? Let us discuss. For example, our first example was 2 uh, 2 3 4 2. Let's take 2 3 4 uh 6 5 7 6 5 uh 7 and 4 1 8 4 1 8 3, right? So basically you can just solve this DP question by two methods. You can either go from top to bottom to get the answer, or else you can also go from top bottom to up. First, let me show the top to down how you'll solve this. For top to down, what you do is just take the sum, like you just add uh, to its bottom. Like what is the sum of this 2 and 5, right? For basically, what do you do is you find the sum for the edges. That is, for the edges, you find the sum. For the middle elements, the internal elements, you find the minimum of these two elements. For this, you find the minimum of these two elements. But for the corner elements, you find the sum of this. I hope you are getting. I'll just explain you again. So what will be the sum in this cases? It will be 2. You have to add +2 here to the corners, because there is no directing edge, because there is no two edges. What I mean is there is no two variables. You just have one variable. You just have to add this. So what you get is 2 plus, that will be 5. This will be 6, and for the corner one again, 3 plus 6, that will be 9, right? But when you come to this case, you have to decide among the two variables. Like if there is 5 here, there's a 5 here, right? You have to decide among two variables. You can't add directly 3 or 4. So you have to decide in these two elements which you have to take. For corner case, you can just directly take, because this is the only one which is coinciding. I mean, you have to decide only among one element. But in this case, you have to decide among two elements. So what do we do is we take the minimum of this, and with the minimum element we add this. So in this, the minimum element is 3. So 3 plus 5 will be 8, and this will be how much? 11. Cool. Even for this 6 plus 4, again you have to add for corner elements. There is only one option, you have to add 6. For 3, you have only one option, you have to take 7. Right? But for 1 you have two options. Either take the minimum of these two, right? For 8 you have these two options. I think I'm I think I'm making sense. You're getting a bit, right? So for this 9 plus 4 will be 13, right? So 1 will be here. So the minimum of these two, uh, sorry, did I make an error? For 9 plus so 1, it will be 10. I think I made something error because you have to get 11 here. 3, say 5, plus, sorry, 5 plus 6 will be 11 here. I'm sorry, I'm really sorry. This will be 10. Okay, this will be 10. So minimum of these two will be 10, and 10 plus 1 will be 11. Okay, so this will be more than something 11, 10, right? This will be 18, and this will be 11 plus this will be 14, right? So what is the minimum value? That is the 11. So at the end of the element, you just have to find the minimum of these elements, right? And you have to return the element. This is the top-down approach, basically. Let me show you the bottom-up approach. Basically, bottom-up is a bit easy compared to this one, because you don't need to find the you don't need to add for the corner case and all. I'll just show you. For example, we have, let me take my own example. If it is like this, we have here 2, 4, and we have 5. I'm just inverting the triangle, right? That's what is the bottom of what I meant. So in this case, you just have to take the minimum of these two. For this, you have to take the minimum of these two, and for this, you have to take the minimum of these two, right? See how easy it has become when I just inverted the triangle, right? You don't need to add like the previous one. For the edges, you have to add, right, in the top down. But in the bottom up, you don't need to add. You want to take the minimum elements, right? So it's a bit easy if you're doing like this. I mean, you have to start the for loop. I mean, you have to iterate from here, because you are taking the minimum of this, right? This is I mean, if it is in the position ij, you have to take the minimum of I plus 1 j, and I plus 1 plus j plus 1. I hope I'm making some sense and you're getting the feel of the question, right? That's what we are just solving. We're just taking the minimum of this and we are adding to this, and at last we are just returning the 0 comma 0, that is this point, right? Let's code right now. I think I'm pretty much sure that you have understood the explanation. So yeah, let's code. Let's take this as t for a simplicity. So as I said, we have to start from this edge, right? If you are inverting this, you have to start from this. You have to iterate from here, because we are taking the minimum of this one, right? Of the last edge. So we are taking int I equal to n. Let's store this in n. We have size and n minus 2, and I is greater than 0, I minus minus, and for I int j equal to 0, and j is less than t of 0 dot size and j plus plus. And before this, we have to take something called sum equal to 0. Do we really need a sum? I think we don't need. We can directly add this by just saying p of I comma j plus equal to minimum of p of I plus j and j and t of I plus and j plus 1. That's it. Just return at the end, just return t of 0 comma 0. That's it. That's so simple, right? If you're using the bottom to up approach, bottom to top approach, you get the answer so quickly. Yeah, just sorry, I just realized that I did not put less than or equal to greater than or equal to here. So let's run this again. Yeah, it's giving a proper answer. Let's submit. Yeah, it's working. So yeah, I hope you like the explanation. Uh, I think you got some knowledge how to think differently and go with various approaches. Yeah, if you like the video, just like the video and do subscribe to our channel because a lot more contents are going to drop from this channel. Yeah, keep be safe and keep coding. Bye.